How does long-term space travel affect humans? Astronaut Scott Kelly launched into space on a one-year mission to the International Space Station in 2015. He was weightless for 340 days. His identical twin brother, retired astronaut Mark Kelly, stayed on Earth, and because they are identical twins, Scott and Mark Kelly share almost all the same genetic material, or DNA. They agreed to let scientists study them before, during, and after Scott's mission to find out what floating in space long term may do to the human body. The investigation is known as the Twins Study, and the first results are now in. Genetic changes. In the Twins Study, researchers are looking at 10 parts of the human body. They're doing the investigation for NASA's Human Research Program. NASA is the American Space Agency. They introduced some early findings at a conference in Texas last month. At the conference, researchers said that some genetic changes occurred in Scott Kelly while he was in space long term. John Charles is the chief scientist for NASA's Human Research Program. He says researchers expected some of those changes, but there was a surprise, a change to Scott's telomeres. Telomeres sit on the end of chromosomes. Chromosomes are the part of cells that hold DNA. Usually, as people age, their telomeres become shorter. But when he was in space long term, Scott Kelly's telomeres did the opposite. They became longer. Charles says usually astronauts have shorter telomeres than other people. He thinks this may be because their intense training on Earth is stressful. So being in space, Charles says, may actually be less stressful. They're eating well, they're sleeping, we hope well. They have work that is meaningful to them. They're exercising. They have 2 hours every day for exercise, a luxury many of us on Earth would like but can't afford. Scott Kelly's telomeres shortened again when he returned to Earth. Microbiomes. Researchers are also looking into the twin brothers' microbiomes. Those are the microorganisms, mostly good bacteria, that all humans carry in their intestines to help with digestion. Scott and Mark had different microbiomes, but NASA says that's probably because the men had different diets and different environments. Bone loss. Scientists also compared the two men's bones. They expected Scott to have more bone loss, a known problem connected to weightlessness in space. Sure enough, Scott's bone formation decreased during the second half of his mission, but over the year, the hormone that helps with bone muscle health increased. Researchers say the increase is probably connected to all the exercising Scott did every day to combat the bone and muscle loss. So, while his bones did change, they may end up being just as strong as before. Fine motor skills. The researchers also studied the men's fine motor skills, how their hands and fingers work. To test the skills, the twins performed tasks with their fingers on a tablet computer screen. The early results show that Scott's accuracy and reaction time may have decreased while he was in space. Next steps. As for now, the twin study is continuing. NASA's John Charles says the results will give the agency a new and powerful tool to prepare astronauts for long space flights, including going to Mars one day. If we understand their bodies and how they change in these long-duration space missions beyond Earth, then we can better train them, better equip them, better prepare them, better support them for the missions that they are going to undertake.